Hello! In this video, we will demonstrate how Talend enables you to support a Lambda architecture scenario. Since 2013, Talend has invested in Spark to position itself as the leader in big data integration. With Talend 6, we deliver the most comprehensive support of Spark for batch and streaming processing without the need to write a single line of code. Batch and streaming are not opposite integration capabilities in Talend. We can combine the two layers to enable you to build data-driven application utilizing the Lambda architecture. In this scenario, we will be building a streaming job to aggregate the top 5 page visits per user using the windowing feature found in Talend 6. A Kafka topic has already been created with data already streaming into it, and now we're going to write a simple job to read the data, aggregate it, and give the top 5 records at the time of streaming. So let's get started building the job. We will start by creating a new big data streaming job in our design window and drop in a Kafka topic component so that we can read the input off the topic. In this example, we will name our job Demo Job. First, we will add our Kafka component by selecting tKafka input. Then I will simplify my broker list by adding my host name and port. We want to start the offset from latest and specify the topic name that has already been created for this job. The next component we will need is a tExtract delimited fields component. We do this because when data comes in from a Kafka input, it comes in as a single stream. Therefore, we need to tell this job how we want the data parsed to define our schema for this flow. We will specify our input schema and set our field separator as a semicolon. The next thing we want to do is add a windowing function. We will add a twindow component to allow us to batch our results into smaller segments as it goes through this flow. This way, we can do analytical activities on subsets of our data as they flow through the stream. We will set the twindow duration to 2000 milliseconds, which is 2 seconds. Next, we're going to configure an aggregation component to count the number of hits for this distinct website per user ID. First, we will identify our aggregation schema and create a field placeholder for our aggregation to capture our counts. Now we want to group by user ID and website, and we're going to count the number of views from that website and sort by ascending order. A nice feature of Talend is that you can add a top component in a streaming job that allows you to view only the top 5 records in a large aggregation result. This will allow you to see how your top 5 aggregations are changing every 2 seconds when you run the job. Finally, we will create a tlog row to publish this out to our execution window so that we can see the results in real time. Prior to running the job, make sure your Spark configuration is running in local mode. That's it! You are now ready to run the job and see how your data is changing. In a real scenario, using streaming and windowing, Talend can get a job that is streaming data from website clicks and produce real-time recommendations based on that information to publish out to Cassandra. To see this in action, download Talend's real-time Big Data Sandbox that contains this example and explore it in further detail. Now you can see that Talend has the ability within Spark to handle both streaming and batch capability all in one platform to satisfy the different data velocity needs that your business encounters on a daily basis. I hope you have enjoyed the video. If you would like more information on how Talend can help your business, please visit our website at www.talend.com. Thank you.